Okay, so first thing we're going to do is write down the problem. This is number 25 on problem set 59. I'm recording a video. So it's 4 times a to the negative 1, b to the positive 2 raised to the second power over a to the 0, b to the second power plus 2a times a to the b to the 0 power, a to the negative first power b raised to the negative second power, 5 times a to the third, a to the negative 1, b to the 0, and a b to the negative 1 raised to the power 2 minus 3 times a to the 0, a to the third raised to the negative second, a to the negative fourth, b to the negative second. Okay, and it says that this needs to have all exponents positive. So the first thing I would do is simplify each of the terms, and I would just start with the numerator. So this first one right here, see that we're going to raise that a to the negative 1 and the power rule says that we're just going to multiply those. So I'm going to leave that 4 on the outside for now, and I'm just going to multiply that. So that's going to be a to the negative second power and b to the fourth power. Okay, and then in the denominator, a to the 0 power is the same as 1, and b raised to the second power is just b to the second power. Okay, now I'm going to do the same thing in the second term. Simplify. So a times a is a squared, and b to the 0 power is 1. And in the denominator, that's going to be a to a negative 1 times the negative 2 is a positive 2, and b to the negative second power. Third term, it's going to be 5. And then you see we've got an a to the third and a to the negative 1. So when we're multiplying things that have like bases, we add their exponents. So that's going to be a to the second power. And then that b to the 0 power is a positive 1. And in the denominator, use the power rule again. So that's going to be a to the second power and b to the negative second power. And in that last term, it's going to be 3 times. And this a to the 1 is going to be 1, right? So this is going to just be a to the negative 6 power. And in the denominator, that's just going to be a to the negative fourth, b to the negative second. Okay, now we need to simplify again. And remember that everything in this problem, the answer is supposed to be with all exponents positive. So when we simplify this is going to be 4a to the negative second, b to the fourth over b to the second plus 2a squared, a to the second, b to the negative second minus 5a to the second over a to the second, b to the negative second minus 3a to the negative 6 over a to the negative fourth, b to the negative second. Now we can start combining things that are alike so that we can get positive exponents. So basically just anything that's in the denominator that can be combined with something that's in the numerator or vice versa, we're going to do that. But we want to make sure that our exponent is going to have is going to be positive. So in this first term, in order to make this a to the negative second positive, remember that if we bring that down to the denominator, then it will be a positive exponent. It changes the sign. And then if we bring the b to the second up, that's going to be b to the fourth minus 2, right? Because we are going to subtract because it changes the sign. So that would be b to the negative second. So that means that that b is going to be raised to the second power once we subtract. Okay, and then the second term, the a to the seconds cancel because they're the same. And then that b to the negative second, if we bring that up to the numerator, it's going to be b to the second power. In the third term, the a's cancel. So So that's going to be 5, and then b to the negative second, when we bring it up to the numerator, it's going to be b to the second. And then here, we're going to bring that b to the negative second to the numerator. So that's going to be b to the second power. And then, but we're not going to bring the a up because, see, this is a -4 and this is a -6. So if we did that, then that means that this would still be a negative exponent. So we're going to bring it down. So that's going to be the same as saying a to the -4th plus 6. So that's going to be a to the positive second. Okay, now we combine like terms. So these are exactly alike. So we can just combine their coefficients. So that's going to be a -3b squared. And then 4 minus 3 is positive 1, right? So that's going to be just, and we don't write that because it's the 1 is understood. So that's going to give us b to the second over a to the second. And then this is our answer.